Hello everyone, my name is Sara and I'm your host today, and just waiting a few minutes for everybody to be able to join our webinar. Today we will have a real case implementation of O-PitBlast technology in a field operation with Francisco and Roberto. So if you are getting in the webinar, please let us know your name and where are you from? And if you have any questions, please write them on the comment section and we will answer everything at the end of the webinar. Let us just wait a few minutes. So if you are there watching us, let us know where you're from. Right now in Portugal, it's 9 a.m. Good morning from Italy to Forrester. Hello, Forrester. How's the weather there? Today it's very cloudy in Portugal, in Porto, in Portugal. Alright, so as I was saying, today we will have a real case implementation of O-PitBlast technology in a field operation. So we'll be joined with Francisco and Roberto. And if you have any questions, please write them on the comment section. And Francisco will answer them at the end of the webinar. So it's 10 a.m. in Italy, 1 hour more as Portugal. And it's cold. I'm so sorry about that. It's not cold here, it's just cloudy. All right. We'll wait a few more minutes. Please don't forget to write your questions on the comment section and Francisco will answer them at the end. Today we will have a very special webinar because we will have the office part and the field part connected, so it will be very interesting. And don't worry, because the webinar will be at our YouTube channel and we will share them on our social media so you can watch them later. And a few more minutes and we'll be joined with Francisco and Roberto. Hello, Yarko and Joanna. Hello, welcome. So I think we can pass to our speakers of the day. So once again, my name is Sara. I'll be here as your host. And please, if you have any questions, write them on the comment section and Francisco will answer them at the end. And today we will discuss a real case implementation of O-PitBlast technology in a field operation. So I'll see you in a bit and let's pass the webinar to Francisco and Roberto. I'll see you later.
My name is Francisco Monteiro and I'm a sales engineer here at O-PitBlast, and my background is mining engineering, and today we thought about doing something more practical to you, so it's more enjoyable to see, hopefully. So me and my colleague Roberto, we were doing a work for our client and we decided to record all of the steps that we took. So basically data collection, designing, and also execution. So hopefully we'll be able to show everything stage by stage, and we would like you to understand how to use O-Pit surface in your day-to-day operations. So First, before starting, I would like to thank you to our client, Explonor, for allowing us to do this, to use their data into this webinar. And also we would like to thank Esa Pedreiras for giving us permission to record in the quarry during this session. While I'm in the office representing or trying to represent the part of the planning stages, Roberto is going to be in the field, so he's going to be responsible for the execution part. Okay, so I'm doing the planning, he's going to be doing the execution. The idea is that we're going to jump around between me and him during the recording, and hopefully you will get an idea on how we exchange data between me and him to be able to execute the entire plan. So first stage is going to be a collection of the topography data. That operation can be done with a drone, a 3D laser, a GPS survey, whatever you have available. For this webinar, we are using a drone. So basically, we're gonna gather the drone footage. With the drone footage, we're gonna build a 3D model. And with that 3D model, we're gonna import into the software to be able to start planning all of the stages after. So basically, after getting the 3D model into the software, into the O-Pit surface, I'm going to create the borehole pattern. And with the borehole pattern, so the planned borehole locations, I'm going to send it back to Roberto. Roberto is going to execute the drilling phase, and also is going to measure after drilling the borehole locations. Okay, so we're going to do that. And also, if any borehole had any type of deviation. For that, we're going to use another product of us. So that product is going to be the O-PitDev. The O-PitDev is a probe that is used to measure borehole deviation, so basically angle and azimuth, and we're going to do that for the entire bench. After Roberto has collected all of the data, he's going to send it back to me. In the office, I'm going to, with the O-Pit surface, get the information from the O-PitDev, and I'm going to use that information to visualize the critical distance between the borehole and the free face. Okay, so I'm going to try to control if I'm going to have any type of problems about creation of fly rock because the borehole is too close to the free face, or if I'm having any problems about boulder creation because the boreholes are too far from the free face. Okay, so I'm going to try to control that. After that, I'm going to do the charging operation, or at least the planning of it in the office. I'm going to then send to Roberto so Roberto can do the execution of the charging plan. While he's doing that, he's going to be using another product of ours, so it's going to be the O-PitApp, and in the O-PitApp, basically Roberto is going to have the theoretical data that I planned, and is going to be collecting from the truck, the charging truck, the real charge amount of explosive that is being pumped into every single one of the boreholes. After he collected all of that data, he's going to send it back to me, and now I have all of the data necessary to start taking predictions. The two predictions that we're going to be making is in terms of fragmentation. So we're going to look into prediction of fragmentation using the Kurzweil model. That will allow us to understand what type of results I can expect. And the other prediction that I'm going to be doing is going to be the vibration prediction. The vibration prediction is going to allow me to understand if my blast is going to have any impact around in the area around it. Okay, and also in the blast vibration prediction, I can also understand if I need or how much I need to have in terms of radius of protection around the blast, so every single worker and every single machine is in safety. Okay, so we're gonna be doing all of that, and at the end, hopefully, I will be able to show you on the O-PitAnalytics, which is our last product for today, how to compare between theoretical data, real data, and now to understand basically on the changes that were done, how did that influence my blast in terms of what I planned versus what in reality happened. Okay, so hopefully you will be enjoying this presentation webinar, and if you have any questions, please feel free to ask them in the chat. So we have a few colleagues in the chat taking into their hands all of the questions that you guys are putting, and at the end of this webinar, I'm going to be answering all of them. So please feel free to ask anything, even if it's not about the webinar itself. So you can still ask it if you want me to answer it. And thank you for your attention. Hopefully you will like it, and let's start it.
Hello guys, so thank you so much for joining us. As you can see, we are in a quarry here in Portugal, and as Francisco well said, in order to optimize a drill and blasting, the first step is to do a topographical scan. So there we have our own drone. Okay, now let's go and set it up in order to send it to do the scanning, topographical scanning with a drone. Okay, so come on. So there we have it, our own drone. Okay, as you can see, it's nothing too fancy. It's a Phantom 4, but it's plenty enough in order to collect the data. And how we are going to record the data. So first, imagine that you can see the bench over there. Okay, so what we'll do is first do a scanning of the front, like a 90-degree over the top platform of the collar. Okay, then we'll go with the drone a little bit for front in order to collect the free face. We'll turn the camera in a 45-degree in order to collect all the free face data, okay, and the toe. So we'll be taking pictures 1 in 1 meter, okay, in order to have a better quality. Then we'll compile it and use the software to compile everything, the 2D image into 3D, like Pix4D, Agisoft, and so on, to create a topographical model in a DXF or a CSV format. So there we have it, our own drone set up. Okay, you can do it manually if you want, so basically choose 1 in 1 meter, or if you want, you can plan to scan all over your bench automatically. Okay, so let's go, let's turn on, and there we go. So the drone survey is all set. Now back to you, Francisco, in order to process the image and plan the boreholes. Okay, see you soon.
Hello guys, welcome back. So thank you, Roberto, first of all, for taking the survey and explaining how every step works. And now the idea is going to be to compile those pictures, create a 3D model. We already did that previously with this imagery. So I already have the file, because it takes a few, usually around 1 to 2 hours to compile everything. If it's a lot of photos, it will create a lot of points, so it takes a few hours. And now basically I'm going to show you how to import into the software. And basically the only thing that you need, you can use a lot of different softwares to create a 3D model, to compile the photos and create a 3D model. The only thing that you need to be sure is that you export in a file that is able to be read by O-Pit surface. So basically .dxf files, .txt files or .csv files are okay. All of the rest we are not able to work with it at the moment. In the future maybe we will, but at the moment we can't. So be sure that you are using a software to compile the photos and create a 3D model in a format that is one of those three. So once again, CSV, DXF or TXT files. How do we do that? So I'm gonna go over here and I will try to show it with my mouse, so try to follow it up. So I'm gonna click on the topography tab, and the first option in the topography tab is gonna be the import terrain. If you click on import terrain, you should have your desktop or environment popping up. And as you can see over here, I have 3 different files. The first one is going to be the crest line, and the second one is going to be the toll line. I'm going to show after how to import those two. Those will be the definitions for the software on the limits between bench and free face, and then lower bench. In this case, since I'm importing the terrain, I'm going to click on the webinar terrain.txf file. I'm going to click open. And while I open, it's going to be opening a new window. That new window, as it says on the title, DXF, since I opened the DXF file, is going to open. And over here, I will need to select the entity. So for this specific file, I know its points, so I'm going to choose points. You're going to be able to see a preview. And if you click OK, it should jump to the next window where you need to associate each one of the columns of information to a specific coordinate. Okay, so let's do that right now. First one is going to be the X coordinate. Second one is going to be the Y coordinate, and then third one is going to be the Z coordinate. Once that is done, you just need to import the coordinates. The software usually is able to detect outliers. You can choose to delete them or not, depending on the if you are able, or if you want to lose that data to be able to keep the terrain with lower count of points, or if you don't want to, you can just keep them. For this specific file, we can delete them. They don't really make much of a difference on the accuracy of the results. So for this specific case, I'm going to click delete. I'm going to eliminate those points. So I'm going to click yes. And then I'm going to wait a few seconds for it to import. So now that we have the terrain, as you can see over here, I have the 3D model, and most likely you already know this, but this is the bench that I'm referring to for this specific blast that we had to blast. Over here, as you can see, there are some cars, some drill rigs, some people in the bench, but this is where we need the definition. It's where we want to break the rock, and as you can see in this example, it's pretty well defined. So as you can see over here, also there is this material in this shape, creating like a line. So this is the limit of this blast, and basically the idea was to blast all of this. It's not a really big blast, it's a pretty small, but we found it interesting because the wall, as you can see, is in pretty bad shape. So over here you have a lot of fragmentation in the wall itself, and over here, as you can see, the material is more stronger, with less faults and less fragmentation on it. Also, when we did the survey, or when Roberto did the survey, as you can see, still there was some material in the bench. So we were not able to get a lot of definition for the toll line, but we, as you know, in our industry, we work with what we have available. So let's try to make the best of it. And basically what I recommend usually is to change to 2D view. And on 2D view, if you have like a eagle's eye view, that is able to see all of the bench that you need to blast, it's the best way of working it. And now the second step that I'm going to take after importing the terrain is going to be to import the other 2 files that I talked before, which are the crest line and toll line. So let's do that right now. So I'm going to go to free face. On free face, I'm going to click edit. And if you want to create in the software, which was what we did on the first time, you need to click on this icon over here to create a crest, or on this icon over here to create the toll line. In our case, we already have the files, so I'm just gonna import them again. So you click over here where it says import, and when importing, I'm gonna click crest line for the first one. I'm gonna click open. Also, it's a DXF file, so it will open this preview tab. In this case, you can or you don't need to, since the software was already able to detect that the files that I want to import, the entity is the polylines, but you can still select polylines just to be sure and click OK. On the second window that it opens, you basically need to do the exact same thing that you did before when importing the terrain, but in this case you're going to select the X coordinate, Y coordinate and Z coordinate for the crest option. Okay, and now I'm going to import. You should already be able to see the line appearing, and if I change to 3D view, you can see that the line is the limit between, or it's defining the limits between the corners of the bench with the face. Now let's do the exact same thing now for the toe line. So I'm going to go to import, select the file for toe line, click open. Same exact thing, so entity is going to be polylines. I'm going to click OK. Over here, X, Y, and Z coordinate, but now for the toe option. Okay, so I'm going to import that as well. And once you reach this point, you already can start deciding what's your blast pattern going to look like. Okay, so for this case, we went with a 2 by 2.5. So let's create that right now. You're gonna need to go to boreholes. You're gonna have one option over here in the front, which says pattern creation. If you click that option, you will be able to see that my mouse cursor changed to a cross, and also a new window appeared. This new window has some geometrical parameters that we're gonna define right away. First thing we need to do is gonna be to click on the center, or anywhere you prefer, since you are able to move it after. Okay, in this case I select the center, and now on this window, one of the options that I'm going to use is going to be the attenuation. As you can see over here, if I try to get my two lines to fit in my bench, it's going to be really weird because my bench is not regular, at least my face is not regular. So as you can see, if I try to put it like this, something like this, you're gonna have locations where your boreholes are like 4 meters apart from the crest, while in other positions it's like half a meter from the crest line. So the idea is gonna be to use the tools that the software offers to try to create a blast pattern that is not regular, and it tries to attenuate the crest differences between all of the entire crest into different distances between the boreholes and the crest line itself. So you're gonna understand once I start doing it. So if I click over here where it says attenuation, those two pink balls, let me move this window a little bit. So there's gonna be two pink balls appearing, one on each side of the crest line. Okay, so this is the limit of my blast pattern creation, since after that my crest line doesn't reach it. So you are still able to put boreholes there, you just are not able to do the attenuation since you don't have crest line to do it. Okay, now one thing that you can see is that, for example, these boreholes were pushed to the front to keep this distance almost the same as this one, and some others were pushed back. Okay, so basically what the software is doing is looking at the points that I have selected for my crest line and deciding if the boreholes should be pushed back or front. Okay, so after that, as you can see, these were the blast pattern configuration that we went with. So it was a 2 by 2.5 meters. We ended up doing two lines, and on those two lines we did 23 boreholes each. Okay, after you are ready to insert these boreholes, you just need to click OK. The software will start to run and add these boreholes to my terrain, and if I change to 3D view and push it to the side and then remove the terrain, you should see that my boreholes are also vertical. Okay, so this was an option from the client, not from us. In this case, we would recommend a little bit of inclination to the front to be able to keep trying to get the borehole as parallel to the front. Okay, so you are gonna understand once I double click over here on borehole number 6. If I go there, as you can see, since the borehole is vertical, and my face is not. What is happening is that in the top I'm having a 2.8 meters distance, but on the bottom I have 5.05 meters distance. Okay, so it almost doubles the distance from the top to the bottom. Okay, so the idea for us would be to try to give an inclination for this borehole in a way that it tries to get parallel to the free face over here. So for example, just to give you a demonstration, if I go over here where it says inclination on the geometrical parameters and I start pushing it to the front, as you can see, more values will get the green color. So for example, this will be a good position to get my borehole with, so around 10 degrees for inclination. And the azimuth is 180, is the same azimuth as the bench itself. So why does this help us? So as you can see over here, if my explosive has a radius, okay, in terms of breakage, as you can see over here, the rock will be broken almost similar on the top and on the bottom. If I bring it back to the original position, so the 0 degrees, as you can see, on the top I will have particles way smaller than the ones on the bottom. And this may be a problem because on the bottom I may be creating boulders, I may be creating uneven floors. Okay. Also, just to give you the other side of this problem, so too far apart I'm creating boulders. Over here I'm in the good position. If I keep pushing it forward, as you can see, some of the values will turn red. When they start turning red, this is an indication from the software that the critical distance, or I'm working below the critical distance. So if I insert the explosive that I'm planning to use over here, I may create some type of face burst that will end up pushing the rock out and creating fly hawk. And as you all may know, fly hawk is one of the biggest issues that we face with bad plannings for different classes. So let's just push this to the original position. Okay. So for this, the client gave us a restriction, which was that boreholes needed to be vertical. So knowing that the boreholes need to be vertical, and as you can see over here, the face was not really good. So for example, if any of these boreholes deviated to the front using the drill rig, we would have problems, okay, in terms of fragmentation and also in terms of safety because of the fly hawk created. So we had a few concerns, so we added a new stage. So after drilling, basically we went to the field and we gave the drilling plan to the drill rig operator, and he started drilling, and around a few hours after, we were able to go to the field and start collecting the borehole deviations with our O-PitDev system. I'm going to put a video recording also of us doing that operation in the screen, where Roberto did all of the boreholes, and then we recorded the last one, or one of the last ones, so you are able to understand how to work with O-PitDev and what's the importance of this type of tool in an operation like this. So how do we do that? How do we share the drilling plan with the O-PitDev Pro? We're gonna use the O-Pit Cloud. The O-Pit Cloud is a system, or is a cloud-based system that connects all our products, all of our devices, okay? So to use it, it's pretty simple. So you just open the O-Pit Cloud tab. You're gonna choose the project where you are working with, and then we're gonna choose the blast also that we are using, okay? After that, the only thing that we need to do is, in this case, I'm going to update it since it already exists. If you are creating a new one, you just need to upload it. So that's the real difference. So after that, you just need to wait a few seconds for it to upload. And once it's on the cloud, I'm going to push the video so you can see what Roberto saw and did in the field with our O-PitDev system. Thank you, and see you in a few seconds.
So guys, Francisco, as you saw it, planned everything, imported terrain and planned the boreholes on the O-Pit surface, and he shared then later the project with me through the O-Pit Cloud. Now we are on the field and we have over here our O-PitDev in order to measure the borehole deviation, the real one. So we come back with all the goodies, and as you can see here, we have the probe ready to be deployed on the borehole to be measuring. Okay, so let's go. So guys, we are now on the field. As you can see, we have our own O-Pit dev, and now to turn on is simply shake it. The LED will turn red, and now we need to connect with the phone. So we're just entering, open the O-Pit app, select probe. As you see on the side screen, wait a little bit until the probe pop-ups, okay? Now the probe is popping up, simply press it, menu and my files, and the LED will turn green, okay? Now, what we need to do first before starting measuring is calibrating the probe. So in order, again, menu and then calibration screen, okay? Then, if you have already a calibration, you need to delete it, okay? Select the mode, and now we need to start calibrating. How it's done? So for the magnetometer is doing the figure of 8, okay? Keep an eye until it's over. Now the magnetometer, as you see, is done. Now for the gyro, just lay it over on the field, okay? Try to have a flat surface. The gyro, as you can see, is now done. Now for the accelerometer, you need to flip it between different positions. So first you can hold it like this, then you can hold it like that, and start doing these movements until, and wait 10 seconds between movements until it's done, okay? So. A little bit more. And as you can see, now it's all set, so we need to save it, okay? Now, going to the project, okay? We go to the project. As Francisco shared through the cloud with me, I have here all the planned values, okay? Now, I simply go to the project, select it, and we all set to start measuring it. So right now, I all set up with one glove, another is just to press it, okay? But we advise you, and included in the package, there's a touch pen, okay? So please wear gloves and safety measurements. Over here on the borehole, as you see, there's no PVC tube, okay? We advise you as well to put one to protect the probe, okay? So right now, we are going to the project. As Francisco shared to the cloud, I have all the boreholes, all the planned values over here, okay? Simply select the borehole, the step will be 22 meters, and the measurement will be done in uphole. So the first step is going inside the borehole, okay? So as you can see here, the LED is green, so it's connected. Now, if I press Start Survey, it will automatically turn blue, meaning that is in survey mode. Now, we simply drop it down inside the borehole, okay? So, we right now reach the bottom, okay? As you see over here, the measurement is 12 meters, okay? So I can, you now need to insert the offsets. So imagine that the borehole was 11 meters, like here, okay? The offset, as we are doing 2 and 2 meters, is the distance between the measurements, okay? For example, over here, 11, to the next pair measurement, that is 12. So the offset should be 1 meter. In this case, as it's 12 meters, so it's 0. Now I can come here, press 0, okay, and now start survey. You notice that it will beep and vibrate, okay? Now it beep and vibrate, let's pull, okay? 1 minute, 2 meters, measure it again. As you notice, we have a brand new rope, okay? This brand new rope was made together with MTI, a company from Australia, that we developed this rope to be super easy to work, not tangled, and it has a steel core, okay? So, continuing it, another meter, And there we have the probe. Now, as the measurement is done, what I need to do is simply press enter, okay? And you are able to see right away the real results. And if we press into the view, we are able to see the 2D view from the side, the back, the top, and the resume, okay? Now, as we are working online, all this information is directly uploaded to the cloud, okay? And basically Francisco right now on the office can update the borehole, okay, the blast, and we'll be able to see all the deviation, the right deviation from these boreholes, okay? The idea is to perform from all the blast, the QA/QC regarding the deviation to better analyze it, okay? So keep enjoying. Let's start doing this of the all blast, okay? See you soon.
Hello guys, welcome back again. So as you saw, Roberto did the probing of all of the boreholes with the O-Pit probe, and he recorded, as you saw in the video, one of those. He explained a little bit how to do the measurements itself, how to do the survey with the probe to get the real data for the azimuth and angle. And now I'm going to show you how to bring back that information into the software. Redo the critical distances, try to understand if any of the boreholes is outside of the acceptable range, and also I'm gonna then create a charge rule, and that charge rule I will implement in all of the boreholes, and then I will send again, or I will update the blast plan in the O-Pit cloud. That way Roberto in the field is able to visualize what I prepared in terms of charge rule, so it can control the charging operation in the field directly with the mobile app. So let's start doing. So we're gonna go to O-Pit Cloud. On the O-Pit Cloud, as you can see, I'm selecting the blast. So we now are gonna start. As you can see, now I'm into 3D view. If I take out the terrain, as you can see, I have my boreholes, my vertical boreholes that I planned before the last video. And now the idea is going to be to download the real information from the boreholes. So I'm going to do this, I'm going to do download. We're going to wait a few seconds. Okay, so now I have my plan updated. Let's just zoom in a little bit on the blast location, and let me take out the terrain. And as you can see over here, so I have my theoretical boreholes, those are the ones in blue color, and then if you look into the boreholes, you will also be able to see a red line indicating the real measurement. So as you can see, if I zoom in a little bit, each one of these lines has red spheres over here, and this is the points where the probe took a measurement, okay? So basically the software is connecting all of the measurements with this red line, so you can better visualize the deviation occurring. So I'm going to go back to the 2D view. From the top, as you can see, the boreholes of course got a little bit of a deviation, as it is normal since it's a top hammer, and as you can see, some of them deviated a lot more than the others. So for example, as you can see, this one didn't deviate at all, so it's almost vertical. These ones deviated a little bit, the 42 and 43, but for example the 40 deviated a lot, and also 34, 11, and I'm not really worried about this type of deviation. Why? Because as you can see, they are deviating to the front. So even though the client told us that they wanted to do vertical holes, as you can see, I told before that a little bit of an angle to the front would be better to try to keep the critical distances, or at least the borehole positions, as parallel to the front, to the free-faced angle as well, would be the best option. and as you can see, the boreholes end up deviating to the positions that I said, so I'm not really worried about these borehole positions, so that's okay to keep going forward. And bringing back the terrain, let's, for example, double click one of them. And when double clicking a borehole, as you can see, before, when I showed this tool, the software was calculating the critical distances between the planned borehole and the free face. In this case, as you can see, now it's doing the distances from the real values, so the real position of the borehole, to the free face. And as you can see, now the top measurement is more similar to the bottom one, even though of course there are some boreholes where the top is way closer from the borehole to the free face than on the bottom. So I'm just gonna jump between some of them. What I'm looking is try to see if any of them deviated more than what's acceptable. So if that happens, so for example over here on this one, as you can see, my top values are with red color, then my middle ones I have green color, and then my bottom ones I have blue color. See, this is an indication that this one is farther apart. The green color indicates me that the distance that I have between my borehole and my free face is acceptable, is okay, it's perfect. And the ones on the top, it's less than acceptable. Okay, so for example, 1.7 meters is too small of a distance. So if I put explosive on the top part of the borehole number 9, this will push the material forward with enough strength that it will just shoot the rock and create fly hawks that may reach the outside area of my safety radius. So the idea for this specific borehole, number 9, most likely it will be to just up the stemming, so I will not charge it until the top. I will most likely just charge it until this level, and then I will increase the stemming to prevent any type of face burst occurring on the top of the borehole. Okay, so the idea is going to be to jump around on the other ones. So mostly green colors, blue colors, acceptable boreholes. Number 4 may have the same problem as the number 9, so number 3 as well. Number 2 is okay. Number 1 may also have this problem. If I put it from the side, it seemed way smaller over here, but it's just the visualization itself. So you can look around like this to try to understand what's the points of critical or minimum distance between the borehole and the free face. So let's turn it off and let's jump to the next phase. So as I said, now I looked into the boreholes. The idea was to point out which boreholes had problems in terms of critical distances. Those boreholes need selective charge. The other ones can be just generally charged with the normal charge rule that you implement in your operation usual, so day by day. So how do we create the charge rule, and now we put all that charge rule into every single one of the boreholes or specific ones? So I'm gonna go over here to charge option, and then I'm gonna go over here where it says edit rule. That will open a window, and on that window you will be able to create a charge rule. Okay, so for this specific blast, as you can see, I created over here a charge rule for demonstration purposes, and this one is the exact same one that we use for this blast, which was a booster for 150 grams. We used 1 unit of booster on the bottom, as you can see over here on the preview on the right side, and then we filled the borehole with emulsion 125. As you can see over here, 100% of my borehole is filled with the emulsion. After you create, you will hit the save button and you can close. After that, over here you can select that you want to enable this tool, okay, Over here, you're going to choose which charge rule you're going to apply. In this case, I only have one, which is the one that I'm using right now. So I'm going to choose that one. If you have multiple, you just need to look for the name that you created your charge rule with. And on the bottom, you're going to select which boreholes you want to apply. Okay. So as I said before, you can choose to apply to all of them, or in the specific boreholes where you find problems in terms of critical distances, you can choose not to apply the charge rule into those. Okay. The way that you can do that is by using this select option. Okay. So using the select option, you will be able to select specific areas where you want to apply charge rules, or using the control button on your keyboard and also clicking on the specific boreholes that you want to apply other type of charge rules. Okay, so you can do one way or the other the selection option. For this case, let's start by adding the charge. If you don't have any selection done, it will ask you if you want to charge all of the holes, and if you are happy with that condition, you can just click yes. And if I zoom in right now, you will see that all of my boreholes got this red circle around it. Okay, so the red circle around the borehole is an indicator that the borehole has charge. Okay, so if I double click again on the borehole and opening the borehole, if I go to the charge window, as you can see now I have my charge applied to the specific borehole that I clicked. In this case it was number 10. So over here on the right side, as you can see on the bottom, I have my 1 unit of booster for 50 grams. Then I have my charge column. In this case it's 100%, which is equivalent to 51.1 kilos. Okay, and that is equivalent to around 1 kilogram per cubic meter. Then on the top I have my 2 meters of stemming size. Okay, now closing this one, so now I have the charge plan. Okay, the idea is going to be to, if I want to go to blast results, and over here I'm going to go to the burden distribution values. And over here, as you can see, it will give me a heat map indicating me where my areas of danger are, basically. So as we saw before with the critical distances, the blue areas was an indicator that the distance between the charge and the free face, so the borehole location and the free face, was further than the critical distances, so these areas are okay, even though they sometimes may create boulders if they are too far apart. The green areas indicating me that the distances are perfect, and the red areas indicating me that the distance is below the recommended values. Okay, so for example, for this case I would need to up the stemming size, most likely in all of the boreholes. As you can see, all of them are with red indicator color, so we can do that. I'm gonna go to the burden distribution, and I'm gonna go now to my boreholes, and we can click on edit hole, all blast holes, and then over here where it says stemming, I'm gonna do a 3 meter stemming, and I'm gonna click apply. When applying the 3 meter stemming, you can now go to the blast results again, or you can click on the borehole to open the window. And as you can see now, if I go to the charge option, you will see that the explosive amount will be decreased automatically. So the software automatically decreases the charge amount to be able to incorporate the new measurement for the stemming that you just put. So before it was 2 meters, now it's 3 meters. And if I click over here where it says burden distribution, it should be better in terms of red coloring, so we should minimize a little bit the red coloring that was appearing on the top position. So now, as you can see, Now my red areas have almost like all disappeared, even though I have a few areas where I have red coloring. That's because my borehole deviated to the front, so most likely it's a little bit below the recommended values, but this blast I would consider it acceptable. So most of my blast area, most of my bench is as a distance to the free face, which will not give me many problems in terms of fly hook. Of course the material will be pushed, and most likely some material will be being projected a few meters, but nothing to worry about for this case. So the idea now is going to be to update the information on the cloud again, so that way Roberto is able to see directly on this mobile app the information for the charge amount that I planned for these boreholes, and also be able to control the charge operation in the field with the truck, the pumping of the emulsion, so that way after instead of having the theoretical amount per borehole, I will have the real amount of charge, of explosive charge per borehole. Okay, so I'm gonna go to my project, I'm gonna go to my blast, and then I'm gonna update my blast. As you can see now, my blast was updated, so I will now run the video of Roberto showcasing how to do the charge. So please, Roberto, take it away.
So guys, we are back to the field. Francisco already told me that he updated everything regarding the theoretical part. So the length is okay, the charging, the planet charge is okay. And now he shared the project with me, okay? So over here on the O-Pit app, I can enter in the project that he invited me and see the blast that we are working with, okay? Right now, we have the list of the boreholes, and as well, we can see the 2D view of the boreholes, okay? Now, we simply start from the side and organizing the boreholes to come and to do the QA/QC. So if we enter a borehole, we are able to see, for example, behavior characteristics. So if it was deleted, and justify what happened, okay? Water presence, re-drill, so anything regarding that. And now, for example, in the charge, we have the theoretical that is 50 kilos, okay? And in reality, it was 50. So everything good as planned, okay? Then we have the geometrical properties as well. So imagine that the borehole that we encounter is a little bit longer, so we can adapt it and get the real length to the O-Pit. The stemming control, diameter, angle, and azimuth, so we can do all of that. Not only that, but also we can put the truck number, so information regarding the truck, the number of primes, the temperature, density, and in the end we have, for example, some comments and some pictures that we can add it, okay? After all the QA/QC is done, if you are working online, every information will be saved, okay, and transmitted to the cloud. If you are working offline, it's simply uploaded to the cloud, and Francisco now can update it and see all the work that we've been doing, okay?
Thank you, Robert, for that explanation. So now we saw the O-Pit app. Roberto explained how to use it, and the idea now is going to be to bring back the information from the O-Pit app back to the software, the real information for the charge amounts. So we do that by going to O-Pit Cloud. Then we click the project, the specific project we have been working on, and also we click on the specific blast that I'm also working on. After that, instead of doing update, I'm gonna do update host. So I'm gonna click on this icon that has the cell phone icon, and on this window, as you can see, we have on the top the real information for every single one of the boreholes. So the idea now is going to be to choose what I want to do with this information. So as you can see over here, I'm choosing the option to update the information on the O-Pit surface based on the real data that came from the field. Okay? So now what we need to do is click OK and now look at the results. When clicking OK, as you can see, the software will give you a warning and also a question indicating if you want to proceed with the operation of updating the planned data with the real data. Okay, so I'm going to click yes, and you're going to wait a few seconds for it to update. Once it updates, it will close automatically the window, so you are sure when it's over. So you can close the O-Pit cloud, you can go to the specific boreholes, and you can see the real charge amount for every single one of the boreholes. Okay. Now the only thing we are missing is the timing, and in this case we use non-electric systems, even though the software also has electronic, but for this case we use non-electric. And as non-electric, we use 17s and 25 milliseconds surface connectors, and also 500 milliseconds for in-hole detonators. So basically, first thing I need to do is put those choices over here. So surface detonator or surface connector is going to be the surface connector 17 milliseconds. And then for in-hole detonator, we choose the 500 milliseconds in-hole detonator. So to start adding the time, I'm gonna zoom in a specific area over here, and basically I'm gonna start with the add timing, since I already showed them over here. And the idea is that you connect the first borehole and then you go to the next one, as I'm doing right here, like this. So I move it around to the side and I do the next one. We have a few tools to make this operation easier when we have a lot of boreholes, but in this case there are few boreholes, so there's not really a point in using those at the moment. So I can just quickly connect all of those with the add timing option. So something like this, going all until the end of the line, and then I'm gonna connect these to this one, I'm gonna connect these to this one. Don't worry about them going off at the same time, because I'm gonna fix that part after. So this one to this one. So now we're gonna change to the 25s over there, and I'm gonna connect between lines. And in this case I'm gonna keep the 17s because I want the first line to go off first, but I'm gonna change the timing on the second line. Since I'm changing the timing on the second line and I have the same number of boreholes in front and in the back, I'm also going to change them in the back. So this one is going off with this one is going off after this one, before this one is going off before this one. So if this one is 25, I'm going to also delay it over here, just to keep the line after going off after this one, even though I have the initial 25 delay making that happen. So just to be sure, I'm gonna also change 25s over here and also over here. And same thing on this last one, where I'm gonna do 25. So this one goes first, then this one goes, and with the other 25s on the last line over here, everything is set up. So basically this was the connection that we went with. And to make sure that this is gonna work, you also have over here at the end a simulation tool. So with the simulation tool, I'm gonna do a simulation slower. So basically nothing is happened because I'm still missing the initiation hole. So since I'm doing non-electric timing, I need to tell the software where is gonna be my initiation hole. So the timings that you are seeing in the screen are the nominal timings. And if I click the borehole that I chose to initiate, the software will calculate the cumulative timings. Since I'm using an in-hole of 500, the first borehole, since I chose it to be the initiation hole, is going to present me 500 milliseconds timing. With the 25 nominal, it's going to be a cumulative in that direction of 525. And if I go until the end of the lines, I will see that the cumulative timings are being calculated through the nominal timings. Now, once again, let's try to do the simulation. And now doing the simulation, as you can see, my blast pattern is starting off over on this side, is going off in this direction, where the ones in the front are always going off before the ones in the back. So this one goes off, then that one, and then a little bit later the back line. let's just wait for it to finish. So this is the initiation of the blast pattern, and a few seconds later, since this one is ending up at 420, this one is started at 500. So basically my first detonation occurred after my entire blast pattern was initiated. You don't really need to do that, but we did in this case. So as you can see, first, second, first, second, first, second. So one in front, always first, and one's in back. So looking at the blast after this change with the 25s in the back, maybe you will not need it. You could keep it as 17, but in this case we went for it. Now, what I wanted to show you, after the timing, you are able to take results in terms of the blast. What I mean by this is, I already showed you this tab when I showed the burden distribution, but now I want to look into a different option, which is going to be the prediction of fragmentation. Clicking on the prediction for fragmentation and waiting a few seconds, it's going to open this window, and on this window basically you have the initial predicted curve for fragmentation after blast. Over here at the bottom you can see that the model is based on the Kurzheim fragmentation model, and the actual results may vary, may be different from the prediction, mainly because what the software intakes as theoretical data may not be accurate representative of what is happening in the field. Of course, if the data that you input is complex, is complete, and you input a lot of data, most likely it will be, but in some cases that's not possible. So basically you have a few parameters on the right side where you have the different type of rock, the explosive amount, the blast pattern geometry parameters, and basically with those conditions the software will try to predict the initial fragmentation curve. You can save this one as initial and make changes to try to understand what I can change in my blast parameters to then achieve an optimal fragmentation curve after blast. So that way you are able to feed the primary crusher easily without doing or without needing to have a step where you do secondary breakage, okay? Which most likely it will be mechanical, and that usually takes a lot of time and also increases the cost of your operation. So after that I would like to look into the mapping. So we're gonna try to predict the vibration, and we're gonna see if this timing is optimal for the structures around me. So the software is able to measure or at least predict how much vibration you're gonna have around the blast, and knowing the limits of the structures around the blast in terms of vibration, the software will let you know if you are working above that limit or not. If you are working above that limit, you are not allowed to blast, so you need to make changes to the timing, to the charge amounts, maybe to the blast parameters, to the blast pattern, to then be able to blast. If we are obliging to the critical values for the vibration, then there's no need to re-change everything to be in compliance, since I'm already obliging to it. So let's look into that. Going to the map option. Also, another thing that I would like to say, maybe before starting the map, there is a tab for attenuation law. The tab for attenuation law, basically you import seismographic data into the software from seismographic stations that you have around the blast area. So that way you are able to create an attenuation law that will be used for the calculation or the prediction of the vibration around the blast when you blast. So if you have that information, if you have the seismographic information of that location, you can import into the software. The software will give you an attenuation law, and that attenuation law can be used over here where it says attenuation to then calculate the PPV around the blast. In this case I'm using data from the quarry, from this location, so I already built the attenuation law. So we're gonna then start calculating, and if I zoom in over here, As you can see, this is my location of center of blast. It's a little bit to the side, so I'm going to put it in the correct location, which is over here. As you can see, this part coming off with this wall over here. So this area over here is the one that I'm going to move my center of blast. And now that I have my center of blast located, the software will start calculate this radius. These radius are taking into consideration the attenuation law from the data that I imported into the software and I built the attenuation law with, and also it's taking into consideration the maximum instantaneous charge that the software is calculating for this timing and also these charge amounts, which in this case is going to be 90 kilos per each millisecond, per 8 milliseconds, sorry. So in this case, if you put your mouse on top of the center of blast indicator, it's going to give you also the MIC amount. If I put the mouse on top of the first radius that it's showing me, which is at a distance of 100 meters, I will have a PPV of around 26.5 millimeters per second. So this is the vibration that the software is calculating for 100 meters around my center of blast. This interval can be changed over here. So, for example, if I want to calculate every 50 meters, I just put there 15 meters, and I know that at 15 meters I'm going to have 80.4 millimeters per second. At 100 meters I will have 26.5 millimeters per second. At 115 meters I will have 13.874 millimeters per second. So you can decide on the distance per radius that you want to calculate, and the software will give them to you. Usually I just keep 100 meters because it's the value that comes by default, and it's usually good for what I need. In this case, our main concern was this structure over here on top of the hill, because this structure was not owned by the company that is exploring this quarry. So basically I need to register, or at least control, how much vibration it's reaching that structure. To do that, I'm going to zoom in a little bit. So as you can see, I have here the structure. So I'm going to click over here where it says add structure, and I'm going to click on this structure, which is in a warehouse, and then this window will appear. On this window, I'm going to register what it is, and also the limit, which in this case by default usually it's 15 millimeters per second, and in this case is actually the accurate value, so I'm going to leave this as it is. In terms of colors, you can color code it according to what you necessary, so what you need. For example, you can make a green color for warehouses, you can make a red color for trucks or antennas, so any structure that you remind that you need to register, you can then color code it by category or maybe by value. So for example, I can put structures that are above 13 millimeters per second, I can put green color, below 13 millimeters per second, above 15 I can put orange color, and then below 15 I can put as red color. So I know that just by looking without entering, seeing the value, I know which structures I need to be more careful of than others. Okay, so in this case the only structure that we needed to have a concern was this one. So it's in the warehouse, 15 millimeters per second, so I'm going to add it to my map. And as you can see, first thing that the software will do is going to be create an icon, and then it's going to create this line going from the center of blast until my structure. And if you put our mouse on top of that line, it will give you the distance between the center of blast and the structure itself. So in this case is 178 meters, and for 178 meters, so if you put our mouse on top of the icon representing the warehouse, it's going to let you know what's the predicted value to reach that structure. So in this case, as you can see, I have my warehouse. First line is the name, warehouse. Second line is going to be the limit, which is at the moment 15 millimeters per second. This is the one that I registered. And the third line is going to be the prediction. So predicted is going to be 10.5 millimeters per second. So in this case, it was okay for us to blast with this design as we did. And if the value was above the limit, as I told before, you need to redo some things. First thing I would redo would be the timing. Try to decrease your MIC. Decreasing the MIC will decrease the amplitude of the seismic wave by increasing the frequency. So basically that would be the first option that I would go for. Second option would be maybe don't charge the boreholes as much. So that way you don't have as big as a MIC in each 8 milliseconds. So you're also decreasing the amplitude of the seismic wave by decreasing the amount of charge or the amount of expulsion. So now that I'm okay with this blast, the only thing that we are missing is going to be to send this to the guys in the field so they can charge its timing and also connect the detonators so they are able to blast it. To do that, you have two options. You can, first one gonna be send to the cloud, and second option is gonna be to print and maybe give them the report so they can follow the papers to do the everything in the field. So that's gonna depend on the work that you usually do. And to do the print and preview, you basically go to File and Print. Over here you are able to define a template for the report. So I'm gonna use one where I have the fragmentation and the histogram. There are a lot more things that you can also bring into the report, like map details and everything like that. And over here on the top you have an option to preview and print. So after selecting all of the parameters that you want, you go to preview and print, and it's gonna create a PDF file. And that PDF file, as you can see, I'm just gonna go a little bit quicker through the pages. So first page is gonna be the blast details, some of the blast resumes, like the results in terms of volume and explosive amount used, amount of accessories used, amount of components used. So everything is described over here. Then if I go to the next page, we have the charge rule design. On the next page, I'm gonna have the borehole information. Okay, so the next two pages gonna be that. And on the comments, you have the real charge description, the same way that it was inputted into the OP tab. And after that, we have the drilling plan. On the top, we have the whole number. On the bottom, we have the length. Okay. If the boreholes were not vertical, then on the left side, you would have the azimuth, and on the right side, you would have the angle of the borehole. In this case, since they were planned to be vertical, as you can see, they are showing only with the length, since the azimuth and the angle are 0. After that, we have the detonator profile, where on the bottom I know that I have a 500 milliseconds in whole detonator. After that, I have the tie-up plan over here, as you can see. So basically it's a map showing me the top view of all of the boreholes with the different time options of every single one of those. And on the bottom, as you can see, we have on the left side the detonator time, and if we would have an extra detonator, that will also appear over here. In this case, I'm only using one detonator per borehole, so that's why only one of the timings is appearing. Then we have the charge plan. On the charge plan, as you can see on the top, is also a map option, and on the top I have the whole number, and on the bottom I have the charge amount. The same information that you would have, for example, on the OP tab when I did the real charge. Then I have the rows profile. So row number 1 is the one in the front, where I have 3 boreholes on the left side. Then I have one on the middle, and then I have another one on the right. But the good thing over here is that you can see the deviations occurring, and also you can see the difference. So for example, as I can see, these two boreholes are distanced from 3 meters apart, while this one is 2.1, this one is 1.9. So this will help you a lot understanding where you can be creating different boulders in different locations because of the deviation of your boreholes. And over here for row number 3, so this one is the one on the back, and also as you can see, some of the boreholes were a little bit further than the others, so you can see also or try to understand how your floor will be after blasting. This occurs because sometimes people don't take into consideration that the floor level is not level on the top of the bench. So if you are drilling boreholes with all the same sizes, then you're gonna keep pushing this uneven floor to the next blast over here, the bottom. Okay. And then what we have is a report of every single one of the boreholes from the real data. So all of these are the real measurements that came through the O-PitDev app. And as you can see, there is one per borehole. So I'm gonna jump all of them so you can see some of them over here being described from side view, back view, and then top view. And then we reach the pages of the costs. In my case, since this is a demo, all of the products that I use, the cost is at 0 because the cost will depend on what the client has in terms of contracting, and also which companies you are using to purchase the materials. So as you can see, all of the explosive that I use is at 0, all of the accessories that I use is at 0, and also the drilling cost that I use to drill the 412 meters is also 0. If you input in the software the different unitary prices, then the software will try to calculate overall cost of the drill and charge operation. And then the next pages will be the histogram per borehole and the histogram per charge, where the software will highlight the biggest one. Okay, so for example over here, my MIC, as I told before, is 96.9. That 96.9 is being created by two boreholes, which is borehole number 44 and borehole number 41, detonating in the same time, or at least in a 1 millisecond different time. So they are inside of the 8 milliseconds time window. And the charge amounts that is considering to calculate this is these two over here. And then lastly, the last page of the report is going to be the fragmentation curve being predicted by the software. And over here on the left side, you have the different percentages of material passing on each one of these calibers. Okay. So closing this window, let's go back, and I would like to go now to the O-PitAnalytics, where if you click over here where it says O-PitAnalytics, it will open a window. In my case it opened on the other side, but it will open a window, and on that window basically you can enter with the same credentials that you use for the software, where if you click sign in and wait a few seconds, it will open the dashboard of the account. So in the O-PitAnalytics we have three screens mostly. First one is the overview of the account, where you can see initially on the dashboard the explosives amount that your account is associated with, the number of boreholes, the number of blasts, the number of projects, everything that is associated with your account. And also if you go down, you will see pie charts with the total volume blasted per project, the total explosives used per project, and also the meters drilled per project. In the middle you have the total amounts, and if you go with your mouse on top of specific areas, you will see the specific project usage in terms of explosive, volume or meters. So second screen is going to be the overview of the project. So inside of the overview of the specific project, you have firstly the amount of explosives, blasts, the number of meters, holes and volume per each blast, but compiled into a total volume or a total value for the entirety of that project. Most specifically for this blast, I wanted to show you the specific blast overview, where you can see the compilation of data from theoretical and real and try to compare both of those. So overview, once you click it, it's going to open the specific blast, and the specific blast first is going to be the blast information, where you have the location, the name of the quarry, site or mine, depending on which one you are, and also some general information from the blast, like the blast date and others. Over here is going to be an important one. It's going to be the blasting, basically the blast loading progress, where you can see the number of boreholes that you already charged in comparison to the ones that is total planned to charge. So in this case, we already finalized this blast, so it's 48 of 48. So all of the boreholes that were planned were charged. And over here you can see the different pie charts indicating different categories. So for example, first one is going to be boreholes that were verified by a specific worker, types of errors, errors that were not reported by workers. So for example, this one, it means that there was an indication of an error because the software detected that some data was changed, or for example, it's too far apart from the theoretical data, so it knows that the real data is not the same as the theoretical data, so it knows that some type of error occurred, but the user did not tell what error it was, so that's why it appears as errors not reported by worker. Then no specific errors were reported, so if you report, these will be filled up. After that, you have some blast resume information. Going down, you will have the geometrical parameters or geometrical properties, where, for example, if you put your mouse on top of a specific borehole, you'll be able to see the different properties of that specific borehole, and you can see the difference. So basically, by just moving your mouse, the boreholes will be in order depending on the ID of the borehole. After that, you have relations. So we have relations in terms of spacing burden, planned subdrilling by burden, real subdrilling by burden, planned stemming by burden, and also real stemming by burden. So you can look with your mouse on a specific borehole. So for example, in this case, borehole number 14, you can see the difference in the different data. Also, other properties like volume, both for planned and real, powder factors, you can also compare them, specific drilling as well. So one good thing over here is that you can disable information that you do not want to see. So for example, if I don't want to see the volume, the software will hide, or the O-PitAnalytics will hide that information, so you're just looking at the one that you want to see. After that, we have a comparison on hole details between planned and real in a table method. So for example, if I go to a random borehole, let's go for example 41, let's say, as you can see over here, there was a length change in about 3.5 meters, so that's a difference of 41%. It's in green color because it's above. If it's below, it's going to be in red color. So after, we have a blast top view, where you can see your blast from the top to see where your boreholes are located. And then we have the borehole list, where you can see, for example, looking at the total charge, we can see the amount of explosive that is inside of each specific borehole, and also you have the ID and also the geometrical parameters. Hello again, guys. So I hope you enjoyed this session, and now I'm gonna jump to the questions. My colleagues have been sending me some of the questions, so I'm gonna start with the first one that we have in the chat, which is gonna be the question from Ali. What do you mean by you can do it manually, 1 by 1 meter, or automatically when taking topographical image by drone? So what I mean by this is that you can, some drones have the capability of setting a defined parameter, and for example a route, and let's say the drone is going through the route, and you can set it up to each meter that you go in that route, you are taking a picture. So basically that was what I was saying with the 1 by 1 meter automatically measured. Other things is that, for example, you can do that manually when you are flying the drone. You can put it at a specific, let's say, distance, and with the grid that it appears on your screen, you can take a picture on each vertex of that specific grid. So that's where I was saying with the manually. I hope that answers your question. If not, please let me know again in the chat. The second question that we have is from Zoltan, and his question was, the webinar has been very interesting so far. Thank you, Zoltan. Will it be possible to watch it again later? Yes. So basically, this webinar will be recorded, or is being recorded, and is going to be available in the O-PitBlast YouTube page. So you can check that out. If you go to our page and check where it says, I believe it's live or direct, something like that. But we're gonna also send most likely an email with the recording link. The third question that we had was from Ali. Before measuring the actual hole with the O-PitDev, did you leave the plan with the boreholes vertical? Why not attenuate them to the toe in the first place? Yes, so good question, Ali. We wanted to do it, so we wanted to attenuate the borehole toe to the front in a way that it was almost parallel with the free face itself, but in this case, through client demands, we are not able to do it. First of all, because the operators didn't have the knowledge to do vertical holes, and also I don't think their machines are able to do it as well. Non-vertical boreholes, and their machines are not able to do it as well. So in this specific case, we had to maintain the verticality of the boreholes to be able to do this job. So that's why we didn't do the toe position of the boreholes attenuation to the front. The next question was from Ricardo. I would like to suggest the team to just increase a feature for sound when playing the simulation. I think it would be more incredible. Yes, I'm not sure if that's in the plans in the making. At the moment, we are developing a second version of the software. In the second version, there will be a lot more features than this one. So this may be one of them. I'm not really sure, but hopefully in the future, we'll be able to do it. The next one is going to be from, sorry if I'm saying your name wrong, but I think it's Bjarki. And Bjarki's question is, are there any information about the design of the drill bit besides the diameter? So in this case, if you are talking about the software, yes, in the software we take into consideration not only the diameter, but also the cost. So the software is able to take a report on cost. So if you have that information in the database, it will be able to do it. If you are talking in the drill pattern and not the drill bit, then you take into consideration the burden, the spacing, the both on toe and crest situations, and also the diameter. Okay. Jumping to the next one is going to be Tristan's question. Some blasters use smaller diameter charges than the hole to help with the lower burdens. Is there any charge rule for accommodating for that with the face profiles? Thank you, Tristan, for your question. Yes, you are absolutely right. In this case, we used emulsion and we didn't have any sleeve because I know that it's easier to control charge diameters when you are using some type of bulk explosive when you have a sleeve. In this case, the client didn't have that available. So we just had to go with the option where the explosive has the same diameter as the borehole itself, because we were filling the boreholes with bulk explosive and we didn't have any way of maintaining the burden as we wanted. So you know as well, since you do work field, so we have to work with clients' demands and also clients' availability in terms of products, and so that's why we didn't have any type of constraint in terms of diameter. So we had to follow the specific borehole diameter as the charge diameter as well. So the next question is going to be from Amaro. How can I get a free trial? So guys, the free trial we are able to do for anyone that is interested. So if you have interest, just comment on this video or send an email directly to us. Our email is info@opitblast.com, or if you want to contact directly me or Roberto, you also gonna have in the the brochure of the event, you have both our emails, so you can also contact us directly. You can choose one of the other options. The next question is going to be from Mohammed. Hello, can I have the trial version for this software in this course? Once again, yes, for the free trial version you can contact us directly, like I said before, or you can contact our company email, which is info@O-PitBlast.com, which Raquel just put in the chat for anyone interested. Thank you, Raquel. And this course, this is not really a course, more like a webinar. You can have it freely. We're gonna leave it uploaded into our YouTube page, and it's free to visit. And of course, if you want to know more information, you can also contact us as well, and we can have a meeting to discuss more information forward. Jumping to the next question is gonna be from, sorry if I'm saying also again, the name's wrong, but I think it's Irakli. And basically he's asking, how can I change the rock factor? So basically, over the time, the rock factor is going to evolve, and in our database, you are able to make changes to the rock factor. So let's say, for example, in the beginning, you register a specific rock with a specific rock factor. If the general properties of the rock change over time, you can just go to the database before start designing, changing that rock factor to the new one, and then start working. So it's pretty simple to do. You just need to go to the database and change the values or recalculate them. Okay. The next question is going to be from Ali, and his question was how many data needed to create a more accurate attenuation law. So there's really not a defined number. So the minimum number that you need to be able to use the tool is 1. But I can tell you right now that if you only have one line of data, the result's not going to be accurate because the attenuation law is not really precise. So I usually recommend that you start, let's say, with 10 blasts. You collect data from 10 blasts, you put them all into the software, you calculate the first attenuation law. But you should not stop there. You should update your attenuation law with each blast that you are doing. Okay, so for example, for blast 11, you're going to have 10 data from the previous blast, but for example, on the blast number 20, you're going to have 19 data sets from the ones before. So you should always be trying to update the information so your attenuation law is the more accurate for that specific situation. The next question is from Irakli, and will this record be posted? Yes, so basically this record will be both on the YouTube channel, so you can check it out, and also if you have any question, you can also contact us directly or through our company email, which is info@opitblast.com, which my colleague Raquel also posted in the YouTube chat in case you want to copy it through there. I think there are a few more questions from our colleagues, so let me check the chat now. So the first question that I'm seeing on the chat is going to be how the communication works between the O-Pit surface and the O-Pit tab. And this question from Awa. Awa, thank you for your question. So basically the idea on how we connect all of the devices is from the software we send the information to a cloud service, so a cloud storage, and then the O-Pit app, if it has access to that project, will be able to download the specific blast that you want. So the way that it works is through a connection that is done by a cloud service. Okay, and that cloud service is included in the package, so you don't need to have an extra cost to that. No, it's included in the final price of the package. The next question is from Forrester. Hello Forrester, how are you? So with map report, can the software generate a report highlighting PPV prediction at all the sensitive structures pinned on the map? Not at the moment. As I said before, we are developing a second version of the software, and I think there are some ideas on how to improve the map option, and I think that's one of those. I'm not sure, but I think so. Where they're gonna have more detailed report on, and also calculation on the vibration prediction. In this case, at the moment, for the report specifically, the only thing that you can get is the attenuation values, also the MIC values, and also the, for example, if you want to take a picture of the PPV radius around the center of blast, and also safety radius. So the only thing that we don't have at the moment is going to be the sensitive structures around the blast specifically, okay? The next question is going to be from Mohammed, and it's going to be possible to do regression analysis from PPV values to determine a correct value of rock constant. So once again, for this version at the moment, no, but maybe in the next version. I'm not really sure what the team has prepared for the second version, but we are working hard on the development on the second version to be able to give it out that to you. And I know that the map specifically is going to be one of the tools that's going to be highly improved from this version that we have at the moment. So this may be one of the options. I'm not sure at the moment. After that we have a question from someone that the name only appears to me as an F, so sorry if I'm not saying your name, but the question is, probably I lost it, where can I find the total simulated blasted volume in the blast results? I can only find 2 volumes in preview and print. Okay, so basically on the options setting on the software, you have an option to calculate volume. So basically on the options you need to choose how you want the volume to be calculated, and then on the blast results in the software you're gonna have that value specifically. At the moment we only give out one value depending on which one you chose, but maybe in the future with reporting improvement we'll be able to show you more than just one. But you can choose the total value, it's one of the options. Maybe in your case it's not the one selected, so you need to go to the options and change to that one, okay? Next question is going to be from Ali, and there will be a second version of the software. Yes, Ali. Thank you for your question. Yes, so as I've been saying, we are working on developing on a second version of the software, on the second version of the app, and also a second version of the analytics. So we're gonna have an updated version for each one of the products that are contained in the main package of the software. Hopefully in the future we'll be able to launch that so you guys can try it for yourselves, also with trial versions. At the moment, if you want, I can offer a trial version for this software package. The next question is going to be from Mohammed, and his question was possibly to predict air over pressure and sound. We have other tools to calculate that, or at least to help you with that calculation, but the software at the moment doesn't do it itself. These may also be one of the new tools that they are preparing for second version. I'm just not sure. But please send us an email with that question and I can try to get it out to the responsible to see if I can get an answer for you specifically, okay? And that was our last question. So if anyone still has questions, feel free to contact me or my colleague Roberto or anyone else in the company through the email that my colleague Raquel posted in the chat, which is the info@O-PitBlast.com. And thank you everyone for your attention. Just before finalizing, I would like to make an announcement. We are at the moment running a promotion on every single tool that I showed you over here during this day. And that's going to be the Black Friday promotion. And if anyone wants or has interest in it, please contact us. We are offering 25% in the total package as a discount. So it's a good opportunity for someone that wants to try it out and start working with the tools itself. Thank you all. So I'm gonna now pass the seat to my colleague Sarah, which is gonna say a few words before finalizing the webinar.
Hello again. I hope you enjoyed this webinar. It was very different from we are used to do, so I hope you enjoyed it. Like Francisco said, we have ongoing promotion on Black Friday that you can purchase the O-Pit Surface and O-Pit Dev, including the app and analytics, with a 25% discount. So if you still have any questions, please contact our email that Raquel left on the comment section, info@opitblast.com. And please join and follow our social media. We will share everything of these webinars on there, on LinkedIn, Instagram, Facebook. And don't hesitate to talk to us about anything. Thank you so much for being here. And if you are interested and if you can, we are still having another webinar about this at 5 p.m. today at Portuguese time. So I'll see you later or next time, and please follow our social media and hope you enjoyed it. And bye. See you next time.